So in this one, we've got this block. And again, it's not going to let me write on the actual diagram, so I have to draw another one. But that's okay, because on your test you can't write on either. So your gravity force is going to go straight down, and your friction force is going to be going that way. Okay, that's what's keeping it from sliding. And then there's probably some sort of net force in this direction. Probably. That's probably what we're going to be solving for. So in part A, it says calculate parallel and perpendicular force of weight acting on the block. And the reason we need to know this is because when we start solving for that net force, we need to take into consideration the part of the gravitational force that's going to be parallel, right? Because since it's going straight down, part of it is going to be parallel and part of it is going to be perpendicular. So we'll just need to find both, and then we'll use the parallel one when we get ready to, do whatever they ask us in part B. So that's, why they're having us do this. They want to go ahead and, have us get something we need. So our parallel weight is just going to be mg sine theta. And our perpendicular, I'm going to call it perp because perpendicular is a really long word. It's mg cosine theta. And so our block is 80 kilograms. Gravity is 9.8. And then sine, and we'll use 50. Now, it's going to be really important on these type of problems that you put your calculator in degrees. If you have your calculator in radians, you're going to get the wrong answer. And the way I like to, I can check, on my calculator is I can just put like cosine of 50 in, and if you get like a really, really small number, then it's probably in radians and you need to switch it out. But that's just kind of a way that I can tell. If you get numbers where you're like, that seems oddly small, it probably is. That's probably radians. So I just multiplied these two first, the mg, and then I multiplied that by sine of 50, and I got 601 for the parallel and 504 for the perpendicular. So now let's see what they want in part B. So in part B, they're asking us what is the acceleration of the block. So let's kind of break this down. So we know we're in the Newton's application of Newton's law unit, so we know we're going to need forces somehow. There's no way they're going to make us do a problem like this without working on forces, because that's already what we have on our free body diagram. So we know that our net force, or the total forces acting on our object, is equal to ma. So what is ma equal to in this case? It's going to be this parallel weight minus that force of friction, and that's going to give us whatever's going on right here. Okay. So now we can go ahead and we can solve for our acceleration. So I can just, divide by this mass. And then I'll get acceleration is equal to W parallel minus F divided by M. Okay. So now I can take that 601 that I found. The friction, they've already told us that, so we don't have to solve that. That's nice. And then we'll divide by 80. So the first thing we need to do is do the 601 times minus 151. And that's going to give you 450. We're going to divide that by 80. And that's going to give us an acceleration of 5.63 meters per second squared. So, as you see the incline, you're like, oh gosh, this is going to be hard. But it ends up, it's not that difficult. So you just kind of slow down and, take it step by step.